Hi, welcome to the video lesson on proving parallelograms. You need paper and pencil, and just remember that if at any point we're going too fast, pause the video. We have several theorems to go through today, so a little bit of writing. But I'll go through the slides rather quickly, so you'll need to pause in order to get everything written down. Just a reminder, and you should already have this in your notes, that the definition of a parallelogram is that if I have a parallelogram, then opposite sides, both pairs of opposite sides are parallel. So that would be marked with the arrows showing both pairs of opposite sides are parallel. All right, so our first theorem for today is the converse of the first theorem from yesterday. And it just says that if we have both sides, opposite sides congruent, then we know we have a parallelogram. So opposite and opposite here. So if we see a figure marked this way, we know that we have a parallelogram. Both pairs of opposite angles are congruent. So remember, opposite is across from each other, not next to each other. And if we have this situation, then we know we have a parallelogram. And that would be all we would need to know. That's enough information to give us a parallelogram. If an angle of the quadrilateral is supplementary to both, then the quadrilateral is a parallelogram. So that's a little harder to mark, but for instance, if we know this is a 100-degree angle, and we know we have 80 here, and we have 80 here, this angle is supplementary to both of its consecutive angles, so we know again that we have a parallelogram. Here we're talking about the diagonals. So if I draw in those diagonals, sorry about the lack of straight lines. If I draw in the diagonal and I know they bisect each other, so I know this side is congruent to this side is congruent to this side, then I know again that I have a parallelogram. Okay, this allows us to work with the parallel and congruent ideas, but the key here is that it's one pair. So I'm looking at just one set of sides, and they have to be both parallel and congruent. And it could be either set of sides, but it has to be both on one pair. Okay, so let's use some of those theorems we just learned and solve a few quick problems. GHJK is a parallelogram, so we know that much already. Find the unknown measures. So JH is a side, and I know that if I have a parallelogram, those sides are congruent, so I would know this is 8. So JH would equal 8. LH is a part of the diagonals, and I know that if I have a parallelogram, the diagonals bisect each other, so those pieces are congruent. So if KL is 6, LH would be 6. In example 2, we have 105 degrees for angle C. And I want to find the measures of all the other angles. I know if I have a parallelogram, opposite angles are congruent. So I would know angle A is 105. And I know that consecutive angles are supplementary. So they have to add up to 180. So I would know angle D is 75. Okay. These are all of the different ways that we can prove a quadrilateral is a parallelogram. So go ahead and pause the video and get those written down. And now we're going to use those properties or those theorems in order to prove or determine whether or not we have a parallelogram. So if I look at this diagram, I notice that the diagonals are the only things marked. This segment is equal to this segment, here to here, so I know that the diagonals are bisecting each other. And if the diagonals bisect each other, then it is a parallelogram. Okay, so do we have enough information here to determine if this figure is not just a quadrilateral? We know it's a quadrilateral, it has 4 sides, but also a parallelogram. Sorry about that. Okay, so we look at the angles, that's the only information we know, and we know that the angles need to be supplementary if they're consecutive. So 136 plus 44 is 180. And if I go down, consecutive angles again are also 180. So yes, this is also a parallelogram. Okay, so now let's try a 2-column proof. Remember, we always start out in a 2-column proof with marking our diagram with what we know. So we know that angle 1 is congruent to angle 2. So we can mark those. And we have congruent triangles, so if IJK is congruent to LMH, there are parts that we can mark congruent. So let's go ahead and mark, because these sides, IK and HL, are congruent because they're in corresponding parts of the triangle. And I think that those are part of the actual parallelogram, so those would be the most useful parts to worry about. All right, so let's go ahead and write out what we have. Let's start out with angle 1 is congruent to angle 2, and that is given information. And then we decide, what does that tell us? As far as a parallelogram, how does that information help us? Well, I know that if this is these are congruent angles, if I look at this as a transversal and I look at these lines, I can see that they are corresponding angles, and that makes HL and IK parallel to each other. So I'm going to go ahead and write HL parallel to IK. And that is, remember, if we have congruent angles and we know lines are parallel because of it, that is a converse theorem. So that's converse corresponding angles postulate. Okay, so we now have one set of sides, if we go ahead and mark that on the diagram, as parallel. And we've already marked that these sides were congruent. So I have one pair of sides, both parallel and congruent. So if I just get all that down in my proof, I have what I need to show it's a parallelogram. So we weren't given that those were congruent sides, so we need to go ahead and put that in the proof. We know that HL is congruent to KI. And our reason, because we already have congruent triangles, is CPCTC. Oops, let's add that to the given up here to make sure that we get it into the proof that we have congruent triangles. Okay, so step number 4, now we have parallel sides here, right here. We have congruent sides here. Those are the same pair of opposite sides. So we can go ahead and say that HIKL is a parallelogram. And that we have, the reason we would use is one of our theorems from earlier today, that one pair of opposite sides is congruent and parallel. And that's all there is to it. Okay, the next example is another type of proof, and this is a new type of proof, so I'm sure we'll do more in class. But let's start out with a pretty easy example. And when we do a coordinate proof, we use our equations like distance formula if we need it. We use slope. Generally, we use those two things in order to prove that we have whatever we're trying to prove. So we want to prove that this is a parallelogram, and the first thing I did was take those ordered pairs and graph them. And now what I want to do is I want to think about all of the different ways that we had to prove that we had a parallelogram, and I want to pick whichever is easiest. So to me, the easiest is just like we did in the last proof, is to prove that one pair of sides is congruent and parallel. So if we can prove congruent and parallel, then we've done what we need to do. We're going to do that using distance and slope. So first we're going to prove that AB is parallel to CD and AB is congruent to CD. We prove both of those things, then we've proven that we have a parallelogram. So I picked those sides honestly because it's easy. For this particular proof, we do not need to use the distance formula because we're just going straight across, and you can see if I stay at 2 that we're just going from -1 up to 3. So the length of AB, or we just write that AB, is equal to 4. Then we would find the length of CD, and again we're going from -3 to 1, so the length of CD is equal to 4. Therefore, AB equals CD. The next thing we want to show is slope. And we want to show these lines are parallel by showing they have the same slope. Okay, so first thing we're going to find is the slope of AB. And I'm going to go ahead and write the formula out. Remember, slope is y1 minus y2 over x1 minus x2. And what we never want to do on a coordinate proof is say because it looks like it. We need to show mathematically that these slopes are the same. So if I take y minus y, I'm going to have 2 minus 2 over 3 minus -1. And that is going to equal 0 over 4, which is 0. Now I'm going to calculate the slope of CD, and that is going to equal -2 minus -2 all over 1 minus -3. So this becomes addition, so that's 0 over 4 again, and that's 0. So I use the therefore symbol again. Therefore, the slope of AB equals the slope of CD, and AB is parallel to CD. So then we have to draw our final conclusion. And our conclusion is that our final answer is therefore ABCD is a parallelogram with one pair of opposite sides congruent and parallel. Okay, that is it. Make sure you write down any questions that you might still have or questions about the work that we just showed here, and we will be sure to work more coordinate proof examples tomorrow. Thanks.